Welcome everyone for the Social Cybersecurity Working Group. This is the first meeting of 2023. So although it's a month late, but Happy New Year. Hope everyone is enjoying their 2023 so far. Health, prosperity, productivity, and all the best wishes for the rest of the year to everyone. Today we are joined by Professor Manas Gaur, who is doing exceptional work in knowledge graphs, knowledge infusion. So in a moment, we will hear from Professor Gaur. But before we give the floor to Professor Gaur, I would like to introduce everyone who are attending, starting from me. So I'm Dr. Nitin Agarwal, World Energy Chair and Distinguished Professor of Information Science, and also the Founding Director for Cosmos Research Center here in Arkansas. I'm also the co-chair for the Social Cybersecurity Working Group, which is operating under NSF auspices at the South Big Data Hub. So we are really grateful for Chris and the entire South Big Data Hub team for helping us in coordination of these meetings. Now we see a lot of participants here. So what we typically do is go around the room and I ask individual folk to introduce themselves. So I will call out your name and just in one breath, please introduce yourself. So we'll start with Bala. Could you please go ahead and introduce yourself? Again, one breath.
Hi, I am Bala. I work as a scientist at Rutgers University. That's it. Yeah, thank you.
Thank you for joining, Bala. Next, we have Billy.
Hi, I'm Billy Spann. I'm a postdoc at the Cosmos Research Center at UA Little Rock.
Thanks, Billy, for joining. Next, we have Garima.
Hi, I am a PhD student at ASU.
Good to have you, Garima. Next, Heather.
Yes, Haider Al-Rubaim, and I am part of the information science department, and I am doing my PhD right now. I'm a PhD candidate.
Have you, Heather? I believe next we have Diana.
Hello, everyone. I'm a research assistant, graduate research assistant at Cosmos Lab, and I'm currently doing my master's at ULR.
Nice to have you, Lieutenant. Next, we have Marina.
Good morning, everyone. I am information science student at ULR and a fellow cosmographer. Thank you.
Good to have you. Next, we have Nilofer.
Hello, everyone. I'm a research assistant in Cosmos team, and I'm in my second year of PhD in information quality. Thank you.
Good to have you, Nilofer. Next, we have Obianuju.
Good morning, everyone. I'm a research assistant with Cosmos and a master's student as well in University of Arkansas Little Rock. Thank you.
Good to have you, Obianuju. Next, we have Rejab. Perhaps Rejab has issues with his microphone. We will come back to you, Rejab. We have Vanessa next.
Hi, everyone. Good morning. My name is Vanessa. I'm a research assistant at Cosmos and also a master's student at the University of Arkansas at Little Rock. Thank you.
Good to have you, Vanessa. Last not least, we have Stephen. Stephen, please go ahead.
Hello there. My name is Stephen Dick. I'm a newly hired research associate at RMC Research.
Good to have you, Stephen. All right, I think I've gone through everyone. Rejab, if your microphone is still giving you trouble, you can tell us about yourself in the chat. I will be monitoring chat for the rest of the session. So it is my distinct pleasure to introduce Professor Manas Gaur, who's going to talk to us about targeted knowledge infusion to make conversational AI explainable and safe. Manas is an assistant professor in the Computer Science and Electrical Engineering Department at University of Maryland, Baltimore County. Before UMBC, he held the position of Senior AI Research Assistant with the Knowledge and Dialogue team within the AI Center at Samsung Research America. He completed his PhD in computer science from the Artificial Intelligence Institute at the University of South Carolina. His PhD research was supported by Eric and Wendy Schmidt, Data Science for Social Good Fellowship, AI for Social Good Fellowship from Data Miner Inc., EPSRC UKRI grant through Alan Turing Institute, and NSF Eager on knowledge-infused learning. His most noted work on knowledge-infused learning parallels neurosymbolic AI in mental health. His research focuses on knowledge graphs, natural language processing, artificial intelligence, and conversational systems for social good applications. So that's exceptional work from Professor Manas Gaur. And with that, I would like to turn it over to Professor Gaur for his enlightening talk.
Thank you, Nitin. And thank you, Chris, for inviting me. And I want to share my, yes, I think my screen is visible.
Yes.
Okay, I want to, I think this should show. Awesome. So thank you, everyone. And thank you all for being here. And this talk today that I wanted to talk about is also a part of the AAAI new faculty talk that I will be giving at Washington, DC AAAI conference this year. And essentially, this the work that I will be presenting towards the South Big Data Hub Working Group workshop is along an idea that I have been working for past couple of years, and it includes a lot of the data, the information on conversational AI. But most importantly, I wanted to enlighten you all that why we need knowledge infusion in making conversational AI explainable and safe. There have been a lot of discussion recently with the first safety workshop in conversational AI started by Microsoft and Facebook. And over the time, there have been a need for explanations and safety when you are dealing with conversational agents, because they are AI based and they're automated. So just like what you are getting is what you're giving to the model is what you're getting from the model. So I wanted to make this talk to be more specific to the sensitive domains of AI, where AI adoption is really of critical concern, and there have been some work along that line, which I will be discussing and motivating this today's presentation on the knowledge infusion and how targeted knowledge infusion occurs in AI. Onto this, let's start with a very generic scenario that I was enlightened with last year when I was interacting with DALL-E, and I gave a simple query, essentially, which is very easy to understand to all the folks who are in machine learning and artificial intelligence, that I'm actually looking for an architecture that has data extraction, model part training, grid search, and cross-validation as a component in that architecture. But to the AI, it seems like there are multiple words within this query. There is a pipeline, then there is a model, then there's an explaining, there's a model who is training, and then there's a model who can be trained, and it can be a girl and a boy. There are some gender bias issues, but I don't want to go into the details of that because that's kind of have a different turf. But essentially what we are looking into is the segmentation of this entire query into a bunch of words, which has a drastic consequence as it loses the semantics behind the entire query that is being given to the model. On the other hand, if I just do a simple Google search, which is pretty much there for almost like quite a decade now, they use Google Knowledge Graph. So intrinsically, you get the desired query or desired response by simply looking at the query, and you are getting the desired architectures in front of you, which you really need. What if a model, let's take a DALL-E, who would take a retrieval engine that can actually retrieve the sensible images and can utilize these images to come up with a decent response, then such generation would not have happened. So there is a potential where a retrieval-based mechanism can work with a generation, an automated generation mechanism, to improve the capability of generation. Another experiment that I performed was on ChatGPT. We all know that ChatGPT has been a hype and has been what you can say, a terrific work by OpenAI in the context of AI, in the context of artificial intelligence and conversational systems. But there are a lot of improvements that are required, and that's the very reason that ChatGPT has a reinforcement learning with human feedback in loop, that it tries to take the human feedback and improve upon it. But essentially that human feedback may or may not be correct. But what is essential for an agent to deliver is to look at the key concepts within the query and structure the response accordingly. For instance, in this case, if I'm not talking about a depression and a medication that I'm taking, essentially I'm not interested in looking at such a long content which has little to no significance or association with my query. On the other hand, if I would ask a clinician, so this is a clinician's output trace, that if I would ask a nurse practitioner, for instance, that what would you think if you were being asked by such a query, then the first focus point of a nurse practitioner is the person is depressed. And the second part is the person has a connection with Prozac because he's taking Prozac. And there is the counteracting effect, and thus there is some kind of an association between Prozac and depression. So my next question would be, do you really take any medication along with Prozac? Which is a more engaging and more relative response from a human, which can be seen from an agent if the agent focuses on the terms, on the concepts within the query. That was one just example. What if I just take a very simple example in mental health only, but in a very in a non so sensitive case as it was in the previous example? What if I say I'm feeling tired, which is pretty much after days of work, you go home and you're feeling tired. But what is, I add another concept to it, that it's been week since I have slept. Now, the focus of the model is definitely on the sleep, but the sentence it starts with and the information that is built on it, because it's a next word prediction model, because whatever it starts with, it has to follow that sentence. So if it starts with sleep, the rest of the information would be catered to the sleep. Whereas if you look at this query, is essentially looking at some of the terms like fatigue, exhaustion, probably sleep disturbances. And if I can do a simple Google search with this such a query, I can straight away look at the few bad nights on insomnia as the topmost response or related information that I can get on Google search. Now the question is, what's happening with the generation, right? Why the generation is happening in a very uncontrolled manner? Can it be controlled? So those are the questions that can derive our initiative towards explainability and safety. And in this line, DeepMind also analyzed such a scenario and introduced Sparrow, which is one of the good working and a decent conversational agent that talks to human and answers the question using the live Google search, something that we were hypothesizing in the previous slide, right? Essentially, they also use reinforcement learning, which is also the part of ChatGPT. But what they have done is very ingenious, is that they have guided the conversation to 23 rules. These rules describe the safety aspect or safety mechanism of the DeepMind's conversation bot. And what is an interesting point that actually drove my research in the last year, probably the fall of the last year, was this quote by Jeffrey Irving, that dialogue is a good way to introduce safety in AI. Through dialogue, the AI can understand whether it is going in the right direction or whether the generation is acceptable to the human or not. So that's a good deduction to make, that a conversational models can be made AI safe if we are able to utilize conversational data sets carefully crafted for AI to make AI safe in generation. But at the end of this goal, even if the sparrow is out there, the generation component is still a parametric memory. And it has to be focused on some of, was there a question? Okay. So it still needs to look at the concept within the query and do not generate responses which are predefined as a template in a conversational agent. For instance, in this case, I'm sorry to hear that. I can help you with that. It has no connection to the severity. And essentially, ChatGPT does do a good job in just connecting such a query to the helplines so that the person gets the help. But essentially, that is a step towards safety. But essentially, it is also required to walk the person through a conversation piece while passively activating the crisis online or the crisis calls. So those things are actually a part of the safe conversations, because a person who has that kind of a self-help situation, a helpline definition, by giving the definition, would not be sufficient to complete the job. While on the other hand, hallucination has been a very intrinsic component, and that even after adding of the rules would not be sufficient to control. For instance, if I just paraphrase, or even if I ask the same question, let's say in different time intervals, you will see ChatGPT giving you a different responses. Something very similar what GPT-3, which is a precursor of ChatGPT, used to do that. So hallucinating by definition is by that it deviates, the generated response deviates significantly from the subject matter and is often unreasonable, because that response, if it's changing, that means you're changing your definition or your perspective or your understanding to that for that question. That's where we actually step into the concept of explainable AI, and why we need explainable AI as a core component within an artificial intelligence systems. So in 1970, Wick's sense-making theory actually defined what does explanation means. It says that explanations are always a human-centered sentences which make sense to human expert. So they have never been a part of some kind of a heat map or some kind of a weight matrix or an importance score. Rather, they are actually deliberate human-centered sentences or something of the sort that has some sense to human expert. Alternatively, can we look at if we look at this definition from the perspective of AI, can I say this, that explanation from AI are traces of attention? Because we are looking at the attention model nowadays, and all the models that we are working on are transformer-based models. So we say explanation from AI are traces of attention, which are essentially collective experiences that the model is gathering from the training data. Now, the task that we are now entitled to is, how does this AI model, who is gathering collective experiences over the training, can connect to some real-world entities and actionable definitions? If that can be performed, then you are able to introduce an explainability component within an AI's generation behavior. And in this process, what are we gaining? The purpose that we are gathering from this approach is now the AI is able to analyze, and it can be understood easily by the domain experts. And the only goal of introducing this AI explainability is that we do not want the model to generate hallucinating outcomes. Hallucinating means that the generated behavior of the AI is drifting away from the human desired functionality. Over the time, we are having generated different responses. That means that world knowledge is affecting the model in generating the outcome. And that's what, if there is a certain level of connection that the model is making with the knowledge of the real world, such kind of varied outcome would be minimized. So that's where a study of explanations also starts, that there is last few years, there have been work on explanations, but from the system side. Like for the very popular way of defining something is Lime and Chap, which were the prominent explanations-based systems that were being used in machine learning. And this is a schematic of how this Lyman Sharp work. And what is interesting to observe is that knowledge, though can be a part of Lyman Sharp, but they can always introduce new features into the model. And interestingly, you need a surrogate model to verify a black box model. So your original black box model is still a black box. You are just using a surrogate model, a linear model, which are interpretable, which are explainable, and you're using them to explain what a black box model is doing. And still it do not establishes the connection that the learned features of the model are connecting to the real world entities. And that's where even Cynthia Rudin's 2019 paper talks about that we need to drive models that are inherently explainable. And that's where you can actually introduce more explainability aspect within the model natively. So in this case, in the inherently explainable model, if I want to turn the Lyman Sharp to an inherently explainable, I would define such a scenario where I would like the knowledge to be a part of the interpretable feature. I want the knowledge to be able to map any input data to those interpretable features, and I'm making my model, my original model, to be explainable, and I do not need a surrogate model to explain. And that's where we say that such a model are by design they would be explainable, and you are able to check the fidelity of your original model by introducing inherent explanations. So one such example that I conducted in 2019 was that what if I want to define user level explanations, because that's something that I was able to relate with Weick's theory, is that if I have an input text and I'm able to generate some kind of attention maps, which is pretty much doable nowadays from Python libraries. So what we are trying to do here is that we are taking the maps of the heat maps of the model, and they are now these maps are essentially what? They are concepts, they are words. So what we are trying to do is that we are trying to say, let's take a database that has some interlinked entities, and let's just run the database queries over the database queries using these words. Essentially what we are trying to do, we are trying to say that let's just derive a trace of all the entities that are being passed over the entire database and see what are the trace are. Is there any commonality in the trace? And can we construct a tree? Now the question that arises, where do we stop? We stop, heuristically what I thought, maybe it was, it has need a lot of improvement, but what I thought was maybe the prediction that the model has given can be connected to the node in the knowledge in the knowledge base or in a database, which has some similarity with the prediction. And if we reach to that particular node, we can stop the trace. And that's where we want to take that trace and explore whether we are able to achieve any closed labels as the predictions. So this was one of the post-hoc explanation work on how do we introduce user level explanations according to Weick's theory, and even the definitions what Dr. Rudin mentioned. So this makes me feel that there is some kind of a vertical that we are looking into. We have a generative conversational AI at the top, and I'm able to introduce some kind of good enough explanations or foundational explanations, and I can explain them through user level explainability. Can I make these explanations, this classification, a part or intrinsic component of an AI, so that the conversational models can actually benefit from such a classification? If I'm doing a classification at if I say the classification is pretty good and it is very decent and I can explain it, then probably the generation would be explainable because it has some synergy or connection with what we have done as a classification. But how do we complete this particular process? What is a core component that we can start with to have a generative and conversational AI that is explainable and safe? So that's actually the work which even further derived me to work into the mental health aspect, try to look at the various ways agents have been developed over the time, how they have been interacting what type of generations that they do, and is there a way to confirm that this generation is right or wrong. So for instance, this conversation, which is pretty much about nervousness, a commonality that happens nowadays in the university level or in the school going students, the generation with a model are pretty much risky. Essentially, I'm saying risky because they have no connection to verify whether such a generation is of worth or not. I'm now turning this entire generation problem into a classification problem. So what I'm trying to do, I'm introducing a classification component within the generation AI, telling the AI, saying that if the generated outcome, if the generated question do not match some safety guidelines, something very similar to Sparrow, if they are not, if we do not having a connection with safety lexicon, or if the generated questions do not match some existing questionnaires which are clinically approved and safe, potentially the generated outcomes are not safe. And can we change these questions by taking the help of those questions in the medical questionnaire? So there are two problems over here. One problem is a classification problem. Another is with the help of the classification, I'm generating a new sentence, a new question. So there are some simple and effective strategies to come across such a behavior. Pretty much the first is use of external knowledge completely to transform the initial data. Make your initial data very safe so that any undesirable behavior can be minimized to the largest extent. Another possibility is to develop some auxiliary tasks to confirm the natural language understanding capabilities of your model. Is it able to understand the concept within the query? Or you can actually utilize, now in this case, for the auxiliary tasks, you can use data knowledge or external knowledge to develop some auxiliary tasks. Now, when I say auxiliary task, an example can be, if I want to classify sentiments and emotions, that's a larger task. But before sentiments and emotions, I want my model to look at some post tags that are a part and that can actually describe the sentiments and emotions. So that connection, that intrinsic auxiliary task that you're developing to confirm that the model's larger goal or the topmost goal is accomplished, that's what we define as auxiliary tasks. Another point is, how about tagging the data? Now, we all know that deep neural networks actually learns by special tags, some special tokens. Can I introduce some new tags saying that this part of the sentence is knowledge, this part of the sentence is query, this part is about my personal profile or my personal issues or my concerns, and this is the response. That means that's the models should look at this tag and should give a response after that tag. Now, such kind of tagging is kind of cumbersome because you cannot do it on a large scale, but that's one of the potential opportunities where can we automate the tagging of such sentences so that the model can be trained with some specialized tokens or specialized tags. One such example is, how about I use key phrase extraction or key phrase generation approaches, where given some bunch of words, I create a phrase out of those words, right? Like train my model in a unsupervised fashion to generate some key phrases, which are n-grams, 5 grams, topic models, all collapse together in a system. So that can be defined as key phrase extraction or generation approach. Another opportunity, which again a part of ChatGPT, was how about we use reinforcement learning with human feedback. We give out some results and let the user tell me, or let the human tell me whether that generation is right or wrong, and I take that reward and improve upon it. Now, these rewards can be either made it as a system, what ChatGPT does, or you can actually make it intrinsically with the model by introducing some rewards. Now, if I say rewards, how can I construct rewards? For instance, in this query, let's say, bother by troubles concentrating while reading newspaper or watching television. The left side is a generation by a T5 model, which is a legitimate language model, not as the capability of GPT-3, but a good enough capability to be able to execute on its GPUs. So on the right is what you can see as a bunch of rewards that I constructed, saying that natural language inference is one reward. Syntactic scores, I can construct those. There are some metrics who can calculate syntactic scores, and there's another metric who can calculate semantic scores. Now, can I use these metrics to compute a reward to tell me where, irrespective? So this reward is irrespective to your loss function. But this reward tells me that whether the model's generation is going into the human desired behavior or not. So we look at these questions, and then this behavior tells me that which set of questions needs to be generated and which set of questions can be ignored. So now all of these information that we are available, now how do we include them inside the model? We have talked about some of the strategies. We talked about that the knowledge is required. Now, how do we include them? I have given you some high-level information. Let's just dive into with a more concrete examples of how this information can take place inside the NLP. And that's where the paradigm comes into the picture, which I worked as my part of my PhD, which is knowledge-infused learning. How do we include this knowledge as a wholesome part of your AI learning strategies? And that forms the very much start of this upside-down pyramid. So knowledge-infused learning is a method or a class that involves the incorporation of broader forms of knowledge that we have, right? And how do we include them in the AI formations so that they make the model interpretations better? You can interpret the model, and actually the generation or the explanation that you're getting are of user level. You are able to match it to the user's expectations, and user can comprehend that. Let's take an example of a scenario. So this on the left is basically a conversational piece that we were playing around with a lot of conversational agents, and we took this conversation piece from Reddit. And we took this from depression subreddit, which is pretty much the huge community. And the generation, if you see on the left, is a generation by people who are anonymously responding to this person. And if you look at this slides very closely, that the questions that are being asked have never been a part of the topics or the concepts within the query. That means that people who are asking the question are actually reading the content, comprehending it, and then asking the follow-up question. They are not asking the question which are on the topics or the terms that are already present in the query, in the user's post. Whereas if you look at an agent trying to work on it, in this case the T5, we are able to generate some more of redundant questions, because such questions have already been answered by the user. Right now, if these questions, even if you fine-tune the model, they are really good. Like they would be so if I do fine-tuning, I'm making my model very focused on this particular data or on this particular post. So definitely you will get a good questions. But are they safe? Are they good to be asked to the user? So that's where we say that the safety is not there, but essentially still the questions, even after fine-tuning, are very specific to the context. So that means they are not information seeking questions, because that's what the information seeking behavior was being expressed by the user or by the community online. So based on a series of experiments, we found that the conversations probably even after fine-tuning is still unsafe, incoherent. We are not able to find any diagnostically relevant information in the questions. And most importantly, I run my model today, I run my model after a day, and my generations are completely different. So definitely the hallucination is still in the process. So we took this example and tried to look at from the perspective of reinforcement learning. We took the same question, the same post generated by T5. We ran it, we fine-tuned it on the Reddit corpus, and now the generation are still different. And what we are looking at is a good question, but still unsafe. So what we did was we introduced a sort of a reward. Now I talked about the reward in the previous slide, but this is the reward that we were introducing. We say that there's a blood score. So blood score is the largest trained metric proposed by Google, which says that if you are able to generate a sentence that is human understandable and or human comprehensible, it will give a legitimate good score, but it cannot account for the safety. For the safety aspect, what we are trying to do is we want to making sure that the generated question and some clinical guidelines, in this case a PHQ-9, which is a patient health questionnaire, right? I will show you what exactly these are, but let's say this is an elongated list of all the questions, right? So if we have all the list of questions, we want to compute the similarity. And if it is greater than by a particular threshold, I'm counting on it and making sure that it is significantly larger than value 0. And if it is not, then potentially I will be giving it a value -1. So here I'm actually looking at how divergent or convergent is my generation to the questions in the PHQ-9. So this is kind of saying that the generator now has an evaluator network that will tell the generator whether the generated question is matching to the expectations of the human or not. So we are talking about retrieval. There is a part of the retrieval earlier that I started my presentation with. Now we have a generator, but now along with the generator, we have an evaluator framework as well, which is checking that whether the generation are matching the guidelines or not. So this is a manifestation of PHQ-9 questionnaire, which is a set of 9 questions, and every question has a particular score. We are not looking at the scores because that's again a classification or regression problem. We are looking at these questions on the left to see that can we utilize these questions and make sure we are able to find these terminologies in the generated questions. So making so that we can say that generated questions are actually following a clinical guideline. So we ran through a series of experiments along these lines, took T5, fine-tune it, and even third model, which were used through reinforcement learning. We saw significant improvement on the lower threshold of 0.4. When we started to increase the threshold, definitely the quality degraded, right? It was not super high, convincing to be a kind of a deployed system, but it's certainly a work in progress along this line. But what we found that the PHQ-9 based questions can be intrinsically be a part of such a network. Can also be act as a foundation for the evaluation network. So that's where we saw that can we define this PHQ-9. Right now, it was externally a part of our loss function, just computing the similarity. Can we have this PHQ-9 to be intrinsically be a part of that network? Because now that's just a loss function tuning, but can be a part of the decision making of that model. So that's where we introduced the concept of process knowledge, because the clinical knowledges are always process oriented. They are not unstructured, they are structured, and every sequence of question are predetermined. No clinician asks second question first, then the first question based on the scenario. All the questions are asked in a sequence. So what are the things that we want to work on it if you want to do such kind of scenario? The first thing is that we transform the data through a particular knowledge guided question tagging. We just tag the data through the question tagging, right? And let's just say that this is a schematic diagram of how this process knowledge infused learning works. And essentially you can see that there is a flow chart on the right, and there are some constraints, and the black box model is taking a benefit of this process structures and the form of a constraint. So constraint means whether I should do it or whether I should not do it. It's kind of like, say, getting a threshold again, but with a more conscious involvement of the process knowledge. And that's where we stepped into the safety aspect of the model. Now the model is intrinsically going into the safety aspect, where we are now introducing this this notion of clinical guidelines intrinsically inside the model. So safety by definition has 3 features that were according to what I have been in my literature, saying that robustness was one of the reasons for safety. That it is defined as the AI model continues to operate within the safe limit of specifications. Specifications are clinical guidelines or some questionnaires where you are trying to assure that the AI model adheres to these guidelines. And if it does, you're able to show explainability in the model. So the first thing that I talked about, the tagging, this is what I meant by tagging. So tagging means that now every input in my text, I'm now introducing new tags saying that this is Q2, this is Q3, or this is Q3, this is Q3, and this is Q9, so that the model knows that which part of this content is associated to which part of the questions in the PHQ-9. But this is just a data set. We want to enforce that such a scenario or such an approach is a part of the model as well. So this is just an illustration of the PHQ-9. But what we did was we introduced new cross-attention blocks. So now you see that there are 9 cross-attention blocks corresponding to 9 different questions. Now, one can ask me that if you have 9 cross attention blocks, how come the 9 different blocks have sufficient knowledge about it? So that's where we utilize some lexicon, some existing knowledges that people have built over the time in mental health, and we use them to populate the definitions of these blocks, making them have sufficient knowledge so that they can compute the attention scores deterministically. And that's what we introduced as PHQ-9 intrinsically inside the model as an auxiliary task now. Now, these are auxiliary tasks. The only thing that I'm not doing is that I'm not doing a binary classification on different H-type 1, H-type 2, and so on and so forth. But intrinsically, I'm making this block a part of the PHQ-9 questionnaires. And important in what interested me, that I can just replace 9 questions with any other questionnaires that mental health people uses, and this network starts to work accordingly. So what was the benefit of such a heavy exercise that we did? So what you see on the top is a very convoluted attention representation by a self-attention model. And it gives you all the highlighting possible in the content, right? And if you plot this attention map on a plot by computing the similarity between the attention metric, because attention metrics are between 0 and 1. They're always between 0 and 1. If you compute the similarity between that values and the questions, or even see that whether those values map to any PHQ-9 questions, because your highlighting is taken by the words, right? So you take these words and compute the similarity with the PHQ-9 questions. You will see it will give you all the highlighting possibles in the PHQ-9, because there's no way to check which PHQ-9 question had a higher impact on this content compared to other. And that's where we want to look into, can we have more adaptation? So this was my hypothesis, that why would we have such a unique, like a uniform similarity across all the PHQ-9 questions, all the patient health questionnaire questions. But what we need was that if I have a PHQ-9 question 1 to the model, it should tell me what part of the words in the content is highlighted. If I give it PHQ-9 question 2, what part of the sentences or part of the paragraph is highlighted. So if we have such kind of scenario, if let's say I do a PHQ-9 3, there's no highlighting or minimal highlighting, right? And if you have PHQ-9 4, so it will tell me that individual PHQ-9 questions, how they are being illustrated or manifested in the entire content, rather than giving me a very convoluted, dense network highlighting, which I cannot even understand. So what we found only specific questions that are getting good treatment from this content. That means these questions are something that is answerable, or they can be answered from given context from the user. And the questions which did not show up in this list are the potential questions that the clinician or that the model should be asking to the user for more information if it is required. So if you want to do a follow-up questions, question answering systems, then it will give you a list of questions that can be generated by the model over the time to have a conversation with the user. So when I have these bunch of questions, I want to judge which question to ask. So that's where the question comes in. What is the next safe questions to generate? So that's where we created a series of data sets with strategic guidelines. What type of questions needs to be generated? What kind of categories these questions belongs to, so that you are able to generate these questions accordingly. So now till this point, everything is automated. There are all the existing resources. But at this point, you need a specific resource that can tell the safety. And ChatGPT in this case does by human feedback. They made the system online and we were giving the feedback, and that's where the things becomes more relatable. Now, in this case, such a scenario, we cannot make a system online because it can be a detrimental. So we need to make a kind of specialized data sets of this particular kind. So what we did was, in this kind of a data set, we introduced a specific algorithm, which is very similar to what ChatGPT introduced. We, rather than doing a reinforcement learning guided approach or whatever the things that they have proposed, what we were doing is we were defining specific scores that we can compute. The first score is simply the probability of the model. Second is, does the model generated a question of a particular tag or not? So that's something classification. Third point is that, is there a similarity with some knowledge base or some knowledge similarity? That is again a part of the classification task. And the fourth point is still an intersection. So if you see the first question, the first point in this algorithm is a generation, and rest all of them are some sort of classification task that you are introducing. And what you're trying to say that summing up of this whole score is the entire loss score that you are computing into in your model. So safety was introduced by safety lexicons, and explainability was constructed by using the access to the knowledge base in Mayo Clinic to see if we are able to check how much the generated questions matches to the how much of the generated questions are actually have some similarity with the knowledge base. So safety lexicon means like I have a category and I have a bunch of words that can describe that lexicon. And if I want to look at this fourth point, which is the intersection for safety, what we say that anything that has those set of tokens in the generated text that are actually overlapped, or they have an exact overlap with the safety lexicon, that we are able to say that those questions are pretty much the same, or they are decent to be generated. So that's how we are looking at. We identified what questions to be generated. We now modeling which question to be generated from the list that we have, right? And then we are looking into how we are making sure that the safe generation is going to happen in among those generated questions that the model is providing. By introducing this kind of a scenario of explainability and safety, right, irrespective of what RUE score shows and what BLUE score shows, we found that even after introducing such phenomena of explainability and safety through this algorithm inside the model, we are not hurting any RUE score, we are not hurting the BLUE score of the model, but we are definitely improving thus the safety aspect as well as the knowledge capture aspect of the model. Here I'm saying unsafety means that we are making the model less unsafe, that means more safe. It was just that we took the terminology and later on figure out that it was actually safety metric, but we submitted the work as with the title unsafety as one of the metric. And another point was knowledge capture, where we say that how much of the terms are actually getting captured within Mayo Clinic. So definitely that was a huge effect that we do not see too much of capturing with the knowledge, but essentially this is a work in progress and things will evolve over the time. So when some of the generations that we were testing, and especially this particular example, we were able to see that some of the questions do map to the PHQ-9. So one question that I have marked star did not show up in the PHQ-9, but we cannot deny that such a question is safe because it talks about some antidepressants which are relevant. So there are some generation which will go beyond the scope of PHQ-9, but that's where you are actually looking at the capabilities of AI, because AI gives you the power of going beyond what is already being constructed by the expert, but with the consensus that they map to something that you can actually refer to or check with. So this was a demo that we developed for the entire agent, which we will present at the AAAI 2023 demo track. And it is a kind of a series of work that we actually did on process knowledge infused learning, specifically trying to introduce explainability and safety intrinsically inside a deep neural network that is capable of generating languages. So in the summary of my talk, I walk you through explainable AI, where I talked about some what does inherently explainable means, what does inherently explainable systems are, in the mental health context, what does hallucinations, risky generations, incoherency, what are they, and how they are how they are being perceived in real world. Knowledge infused learning is one of the potential solutions for where you can actually detect the answerability of a particular content and check that training the model to order the generated question, identifying which questions to be generated, learn how to order them, some kind of introduce explainability by making sure that they match to some existing knowledge source, and ensuring that there is safety by making sure that they are adhering to some safety guidelines or safety lexicons. And to achieve those, we introduce safety through process knowledge infused learning, which is one of the ongoing work. And definitely it is in early stages, but it is a work towards where we want to introduce safety aspect inside our conversational systems. Over the years, there is a series of work, our data sets that we have built, and new metrics that we have also constructed specifically to test explainability, safety, and things of this nature, because these metrics like accuracy and F1 score have already been fall short of. So that was a work that we accumulated into what we termed as a knowledge intensive language understanding tasks. With this, I end my talk. Thank you all for your attention, and I'm open to any questions.